let's talk about the limit of a function in analysis. Let's begin by a definition. Suppose you have two metric spaces. Let X and Y be two metric spaces. Suppose E is a subset of X. Function f maps E into Y. Suppose P is a limit point of E. We write f of X approaches Q as X approaches P, or as you remember the definition of limit of f of X as X approaches P is equal to Q if there is a point like Q which belongs to Y with the following property. For every positive epsilon, there exists a positive delta such that the distance between your function and point Q using the metr in Y is getting smaller and smaller for all points like X in E which the distance between X and P is positive and less than delta. So as the distance is getting smaller and smaller on X, the distance between F and Q is getting smaller and smaller in Y. Note that we are using the meter or the distance in X and in Y. That's why we use d sub X and d sub Y. Also recall the definition of limit point. Suppose X is a metric space. And let E be a subset of X. We say that a point like P is a limit point of set E if every neighborhood of P contains another point which is different from P. Neighborhood, every neighborhood of P, of this point P, contains another point like Q, which is different from P, and Q also is in set E. That's how we define a limit point for a set. So when we are defining the limit of a function, we are actually working with a limit point.